Okay, so looking at this question, when Bill was X years old, Ted was 4x years old. Sometime later, Bill is X squared years old and Ted is 10x minus 6 years old. Find the difference between the ages of Bill and Ted. Okay, so we got all our information needed. So let's put this information in this table format. Future, present, and then top upwards, Bill, Ted. Okay, and in here, let's just put in all the information we know. What do we know? We know that Bill right now is X, Ted is 4x, and in the future, Bill is X squared, this guy is 10x minus 6. So here, from 4x and x, we can understand that the difference between their ages must be 3x, right? Because 4x minus x is equal to 3x. And this difference between their age stays constant even if the years go by, because it's how far apart they are. So with this underlined, we can substitute expression for Ted and Bill's ages. So what shall we do? We shall write 10x minus 6 minus x squared is equal to 3x. You got it? So 10x minus 6 minus x squared should equal to 3x, because that's the difference between their ages. So now that we have an equation, we can go ahead and solve it. So let's take this minus x squared to the other side. So 3x plus x squared is equal to 10 minus 6. Now let's maybe bring the minus 6 to the other side to make it a positive 6. So 3x plus x squared plus 6 and then minus 10x. So like terms we add. So these two are like terms. So minus 10x plus 3x is minus 7x. So rewriting it in the normal format, minus 7x plus 6. So now we have this quadratic equation. So we have the quadratic in the equation in the form ax plus bx plus y is equal to 0. So we have it in this form, right? Now, what shall we do with this? We can further go on and factorize this to get our two x values. So our x values here. So doing that, let me write the actual expression here. X squared minus 7x plus 6. Right, factorizing, let's think of what two numbers multiply to 6 and add to negative 7. It's a pretty good one. At this stage, all I can think of is minus 6 and minus 1. Right? Yeah, that works. Because minus 6 into minus 1 is 6. Minus 6 minus 1 adds up to minus 7. Right? So let's write that as our expression. X minus 6, x minus 1 is equal to 0. So now we know both are x terms, because using the null factor law, which basically states, let me write this out, null factor law, which basically states that this term A times term B, term A times term B is equal to 0. So that should mean that either term A or term B is equal to 0. Okay? Or both of them are equal to 0, because 0 times 1 is 0, 1 times 0 is 0, or 0 times 0 is 0. So using the null factor law, we can say x minus 6 is equal to 0, or x minus 1 is equal to 0. Now we can work this equations out. X is equal to positive 6 or x is equal to positive 1. So now we have both our x terms, x is equal to 6 or x is equal to 1. So now we can put these x terms into a original equation, right? We can put them into an original equation. So how would we do that? So now wait, basically until now, we found out the x terms, right? Using the quadratics and everything. So now we just got to sub it back in. What thing are we going to sub it into? We're going to sub it back into the easiest equation that we can find, that is, I guess, this one, 4x minus x. So let's take x to be 6 for now. 4x minus x, that's the difference of their ages, right? So we can take this x1, so 4 times 6 minus 6, so that would equal to 24 minus 6, that's equal to 18. Or one possible solution is 18, or we can take the other one, 4x minus x. Here x is equal to 1, so 4 minus 1, that's equal to 3. So the two possible solutions, because this is a quadratic, is the difference between the ages of Bill and Ted can be 18 or they can be 3, but they have to be one of them, because quadratics give two solutions. And yeah, hopefully you understood. Good luck.